When selecting wires for a cable assembly that will be installed in a flexible conduit and subjected to continuous movement, it is essential to consider certain factors. Firstly, flexibility is paramount. The wire should have excellent flexibility to withstand repeated bending without breaking or kinking. Secondly, durability is crucial. The wire should be durable enough to resist wear and tear caused by movement and friction. Thirdly, heat resistance is important. The wire should be able to withstand the heat generated by the equipment and the movement within the conduit. Several wire types are recommended for such applications. THWN-2, which stands for thermoplastic heat-resistant nylon-coated wire, Class 2, is a good choice. This wire is highly flexible and resistant to abrasion, making it suitable for moving applications. XLPE, which stands for cross-linked polyethylene insulation, is another option. XLPE wires offer excellent flexibility, heat resistance, and resistance to chemicals. MTW, or machine tool wire, is specifically designed for use in moving equipment and offers high flexibility, durability, and resistance to oil and moisture. FFC, which stands for Flexible Flat Cable, are flat and flexible cables often used in applications where space is limited and provides excellent flexibility and durability. In addition to the wire type, several other considerations are important. Conduit size is one. Ensure that the conduit is large enough to accommodate the wires comfortably without causing excessive strain. Secure terminations are also essential. Properly terminate the wires using strain reliefs or cable ties to prevent them from pulling out of the connectors. Bend radius is another factor. Follow the manufacturer's recommended bend radius for the wires and conduit to avoid damage. Lubrication can also be beneficial. Consider using a silicone-based lubricant to reduce friction within the conduit. Building your own cable assembly can potentially save money compared to purchasing a ready-made one. However, ensure you possess the necessary skills and equipment to construct the assembly correctly and meet the equipment manufacturer's specifications. If you're not confident, consult a qualified electrician. Now let's dive a bit deeper into each of these aspects. Let's begin with the wires themselves. THWN-2, as mentioned, offers a good balance of flexibility, durability, and moisture resistance. The nylon jacket helps protect the insulation from abrasion, which is critical in a moving application where the wires are constantly rubbing against each other and the conduit. XLPE insulated wire provides exceptional heat resistance, which is important if the application involves elevated temperatures. It also has good resistance to chemicals and oils, extending its lifespan in harsh environments. MTW wire is designed specifically for machine tool applications. It's constructed to withstand the rigors of constant motion, exposure to coolants, and potential oil contamination. FFC are a unique option. They offer excellent flexibility because they are flat and thin. This can be advantageous in tight spaces or where a very small bend radius is required. However, FFC may not be as durable as the other wire types in applications with high levels of abrasion or mechanical stress. Now, regarding conduit selection, consider the internal diameter. The conduit needs to be large enough to accommodate all the wires without overcrowding. Overcrowding can make it difficult to pull the wires through the conduit and can also increase friction, which can lead to premature wear and tear. Check relevant electrical codes and standards to determine the appropriate conduit fill capacity. Beyond just the cross-sectional area of the wires, consider the way they lay inside of the conduit. A larger conduit may allow for the wires to lay more naturally and reduce binding. When terminating the wires, use high-quality connectors and strain reliefs. The terminations are often the weakest point in a cable assembly, so it is essential to make sure they are properly installed and secured. Strain reliefs help prevent the wires from being pulled out of the connectors, especially in a moving application where there is constant stress on the connections. The bend radius of the wires and conduit is also important. Exceeding the minimum bend radius can damage the insulation and conductors, leading to premature failure. The manufacturer of the wire and conduit should provide the recommended bend radius. Following those recommendations will ensure the wires are not stressed excessively when the assembly bends. Using a lubricant can significantly reduce friction within the conduit. A silicone-based lubricant is a good choice because it is compatible with most wire insulation materials and does not attract dirt or debris. Apply the lubricant evenly to the wires before pulling them through the conduit. In terms of tools, having the right ones makes the assembly process much smoother and more reliable. Consider using a wire stripper that is designed to avoid nicking the conductor. Nicking the conductor can create a weak point that can eventually break. A good crimping tool is also essential for making secure terminations. Choose a crimping tool that is specifically designed for the type of connectors you are using. Testing is also crucial. After completing the cable assembly, test it thoroughly to ensure that all the connections are good and that there are no shorts or opens. A simple continuity tester can be used to check the connections. A more advanced cable tester can be used to check for shorts and opens and to measure the resistance of the conductors. Consider future maintenance when assembling the cable. Design the assembly in a way that makes it easy to inspect and maintain. For example, you could use clear conduits so that you can visually inspect the wires without having to disassemble the assembly. Labeling is also important. Label each wire and connector so that it is easy to identify them in the future. This will make it easier to troubleshoot problems and to replace components if necessary. Pay attention to the overall design and layout of the cable assembly. Try to minimize the number of bends and turns in the assembly. This will reduce friction and stress on the wires. Also, make sure that the assembly is properly supported so that it does not sag or droop. This can put additional strain on the wires and connectors. Before commencing, consider the environment the cable assembly will operate in. Is it exposed to extreme temperatures, moisture, chemicals, or vibration? These factors can all affect the lifespan of the cable assembly. Select materials that are appropriate for the environment. For example, if the assembly will be exposed to moisture, use water-resistant connectors and cable. Another important thing is knowing the applicable standards and codes. Cable assemblers must comply with relevant electrical codes and standards. These codes and standards specify the requirements for wire size, insulation type, conduit type, and other aspects of the assembly. Ensure that you are familiar with the applicable codes and standards before beginning the assembly. Finally, a record of the cable assembly is crucial. Keep a detailed record of the cable assembly, including the wire types, connector types, conduit type, and any other relevant information. This record will be helpful for troubleshooting problems and for replacing components in the future. This record should include the date of assembly, the name of the person who assembled it, and any test results. In addition to the above, also consider the specific motion profile of the cat track. How fast does it move? What is the range of motion? What is the duty cycle? These factors can all affect the lifespan of the cable assembly. For example, if the cat track moves very quickly, you may need to use a more flexible wire type. If the range of motion is very large, you may need to use a longer conduit. If the duty cycle is very high, you may need to use a more durable wire type. Also, take into account any potential sources of interference. If the cable assembly will be located near any sources of electromagnetic interference, such as motors or transformers, you may need to use shielded cable to protect the signals from interference. Shielded cable has a layer of conductive material that helps to block electromagnetic interference. The shield should be properly grounded to be effective. Grounding is also an important consideration for the cable assembly as a whole. Make sure that the cable assembly is properly grounded to protect against electrical shock. The grounding conductor should be sized according to the applicable electrical codes and standards. The grounding conductor should be connected to a grounding electrode system. The grounding electrode system should be installed in accordance with the applicable electrical codes and standards. Furthermore, consider using cable carriers specifically designed for continuous flexing applications. These cable carriers help to support the cable assembly and to prevent it from becoming tangled or damaged. They also help to distribute the stress evenly along the cable assembly. The cable carriers should be sized appropriately for the cable assembly. The cable carriers should be installed in accordance with the manufacturer's instructions. Think about the long-term reliability of the cable assembly. Consider the potential for wear and tear and take steps to minimize it. For example, you could use a more durable wire type, or you could add additional support to the cable assembly. You could also implement a regular inspection and maintenance program. The inspection and maintenance program should include regular visual inspections of the cable assembly. The inspection should be performed by a qualified person. Any problems that are identified during the inspection should be corrected promptly. When selecting components, try to source them from reputable manufacturers. Reputable manufacturers typically offer higher quality products and better support. They also typically have more experience and expertise in the field. Before installing the cable assembly, make sure that all of the components are compatible with each other. For example, make sure that the wire size is compatible with the connector size. Also, make sure that the conduit type is compatible with the environment. It's important to plan out the cable routing carefully. Avoid sharp bends and tight spaces. Keep the cable assembly away from heat sources and other potential hazards. The cable routing should be planned in accordance with the applicable electrical codes and standards. Document all the details of the cable assembly. This documentation will be helpful for troubleshooting problems and for replacing components in the future. The documentation should include the wire types, connector types, conduit type, cable routing, and any other relevant information. Regularly inspect the cable assembly for signs of wear and tear. Look for frayed wires, cracked insulation, and loose connections. Replace any damaged components promptly. The inspection should be performed by a qualified person. In addition to visual inspections, consider performing electrical tests on the cable assembly periodically. These tests can help to identify problems before they become serious. The tests should be performed by a qualified person using calibrated test equipment. When working with electrical equipment, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. De-energize the equipment before working on it. Lock out and tag out the equipment to prevent it from being accidentally energized. Consider adding a service loop to the cable assembly. A service loop is an extra length of cable that is coiled up near the connection point. This allows you to easily disconnect and reconnect the cable assembly without having to cut any wires. A service loop can be very helpful for troubleshooting and maintenance. When installing the cable assembly, avoid twisting or kinking the cable. This can damage the insulation and conductors. Use cable ties or other fasteners to secure the cable assembly in place. Fasteners should be installed in accordance with the manufacturer's instructions. Consider using a cable management system to keep the cable assembly organized and tidy. A cable management system can help to prevent tangling and damage. There are many different types of cable management systems available, so choose one that is appropriate for your application. Furthermore, consider using a surge protector to protect the cable assembly from voltage surges. Voltage surges can damage sensitive electronic equipment. A surge protector can help to absorb the surge and prevent it from damaging the equipment. Also, ensure that the cable assembly is properly supported. The cable assembly should be supported at regular intervals to prevent it from sagging or drooping. Sagging or drooping can put stress on the cable and connections, leading to premature failure. The support should be installed in accordance with the applicable electrical codes and standards. Before making any changes to the cable assembly, consult with a qualified electrician. An electrician can help you to determine the best way to make the changes safely and effectively. They can also ensure that the changes comply with the applicable electrical codes and standards. Keep the cable assembly clean and free of debris. Dirt and debris can damage the insulation and conductors. Regularly clean the cable assembly with a soft cloth. Avoid using harsh chemicals or solvents, as these can damage the insulation. Additionally, consider using a cable gland at the entry and exit points of the conduit. Cable glands provide a watertight and dust-tight seal, protecting the wires from the environment. They also provide strain relief, preventing the wires from being pulled out of the conduit. Cable glands are available in a variety of sizes and materials, so choose one that is appropriate for your application. Furthermore, consider using a flexible conduit fitting at the connection points between the conduit and the equipment. Flexible conduit fittings allow the conduit to move and flex without putting stress on the connections. This is especially important in applications where there is continuous movement. Flexible conduit fittings are available in a variety of sizes and materials, so choose one that is appropriate for your application.